Okay, so we're going to talk about making models today, and specifically making little models that are delicate and very precise, using a series of small pieces and kind of particular set of tools that will help you make precise cuts and clean attachments. Right? So two things we'll be looking at is one, how to cut chipboard. And what we recommend using is 1 millimeter, the thinnest chipboard you can use, and then how to cut and assemble basswood screens. And so we have a number of examples here. One of the key issues, if you zoom in here, when you're doing the screen, is that it's not just the outer structure that we're worried about, but we have to construct it so it has a series of horizontals and verticals. These outer pieces, the slats, attach to a structure that is spaced more widely. Right? So these glue to these, and then you have the sort of larger structural elements of the building, or in this case, the canopy, right? The roof structure. So we'll look at how to do that. And ultimately, when you put these skills together, you can make incredibly articulate, small-scale models that don't take too much material, but that still communicate very effectively all the detail and articulation, the sort of subtlety of the design process. So I've got a set of tools laid out here that we can talk about, starting with a drafting board and a T-square or a parallel, so that we can draw, for example, this elevation of the lines that we want to work with on a piece of trace paper, and then use that as a kind of form or an underlay to precisely place our components. So trace paper, drafting board, T-square. We have a small cutting mat so that we don't have one of those giant ones that make it difficult to sort of move our parts and pieces around. We have some different sizes of basswood, very thick elements that we will not be using, and super thin components as well. Primarily thin 1 millimeter or 1/32 in imperial basswood. So the key here is to use thin materials and then assemble them, if you need a thicker wall, to build that thicker wall out of a series of thin components. Why do we use thin components? For one thing, when we put those thinner elements together, we're not seeing the edge of a thicker piece of chipboard, right? And so it starts to blend the end of this piece and that face of that chipboard blend together well. Right? And now, because we got some inner structure here, this feels like a solid piece of material. The other thing that we need to think about is when we make an opening in that thick piece, we also have to fill the inner edges of that opening so that it reads as a solid. Okay, so we also need some drafting tape here. We have a scale. In this case, we're using both for measurements and for ripping our trace paper. We have a metal ruler to cut our materials with the cutting mat. And we have perhaps the most important factor, which is the singular correct form of cutting, which is the number 11 X-Acto knife. Some students, especially bad upper level students, will tell you to use the little click knife or a carpet cutter or something. That's very bad. This, we love it because it's delicate, has a super fine point on it, and we can make precise cuts. So again, using the thin material, we still don't want to try to cut through that material all in one swipe. We make a series of cuts so we're not killing our finger or putting down too much pressure, and be patient. Right? Patience is a key virtue in model making. We need a pencil or a pen to be able to lay out our lines, to have the underlay for the screen. We have tweezers because these pieces are very small. We want to be able to pick them up accurately. We have white glue. I tend to prefer Elmer's glue, but students tell me there's another kind of white glue that works as well. The key is that you want the white glue that dries clear, so that when you put these pieces together, it doesn't discolor. Pair of scissors, so that if you go to the bookstore and you buy a big sheet of chipboard, you can quickly kind of tear that down into smaller workable pieces. Very seldom do you need a piece of chipboard larger than A3. And you want smaller pieces, again, so that you can work here and cut without disturbing the rest of your workspace. The second to last tool are a pair of small steel L angles. And these are going to help us when we, for example, want to put two planes together. We can use these once we put glue on them. That will stabilize the two pieces, let them dry, and we can walk away while they dry. Go get coffee or something. The last important tool is the chopper. And the chopper allows us to cut accurately and repetitively smaller pieces of basswood. Right? So we'll put this in, chop it, and get all these pieces to be the same length. So we'll demonstrate this briefly. So let's start by just figuring out, for example, how would we cut these very small but yet very precise holes in a piece of chipboard. Right? What we do, we lay out a larger piece, again something relatively small that can fit on our board. We get it all lined up, and let's say, lack of a better dimension, we're going to pick an 1.5 inches. We'll say this is our height of this wall we're going to make. Run that across, right? So we'll pretend that we're actually going to make a little part of a building that's got 4 sides, and we want all 4 sides, or 3 sides in this case, to be the exact same height. So instead of cutting this one and then going to a new piece of chipboard and cutting another piece and hoping they're the same height, we'll lay them all out together. Right? That way we cut this once, and then we can cut our smaller pieces, 2 sides and a longer face. Let's pretend I'm actually measuring this if I were doing it for real. And we'll cut all that. Now we know our 3 sides are the same height. If I come in here and I decide I'm going to have an opening, very small, thin opening. Right? So this is what I'm going to cut out of that larger piece of chipboard. So undo this. Bring our cutting mat over, that out of the way. And the first thing I'm going to do, I'm not going to cut my smaller piece out of the larger board first. I'm going to cut the window first out of that larger piece. My X-Acto knife. You want to make sure you have an extra blade so you can change your knife. If the tip ever breaks, you unscrew this, replace the blade, and you can throw your old blade away into this little slot and grab a new blade. It's really important that you keep your blade sharp if you want to get precise cuts. So here, if we zoom in, I'm going to cut from here to here, but I'm not going to try to make this whole cut from corner to corner in one swipe. So I'm going to make this cut, and then I'm going to make this cut, and then I'm going to turn the whole thing around and cut the opposite way to get into that corner. If you try to make this cut all at once, you'll end up running past that corner to get it out. All right? So let's do that. Oop, didn't tighten that enough. Okay. So I've got that. Notice I didn't come past that line or that corner. Cut it. Usually it takes about 3 cuts to get through the chipboard all the way. I can rotate it. Now you'll notice I'm doing this, seems counterintuitive, with the cork side up. That's so that I make sure that this is laying perfectly flat on the chipboard. Once I get the groove, I can kind of freehand it so I can see it better. And then we do the same thing with the short vertical ends of the cut. This is easier when you're young like you all and you can see better without glasses, hopefully. Okay, flip it one more time. At this point, we're just punching that kind of corner connection out. All right. We can look on the back side and see if we're connected anywhere. Pull that down. Around. Almost there. Hopefully your projects have minimal amounts of small windows. There it goes. All right. So you could come back later and erase those lines, or you could be more careful when you drew them in the first place so that they're lighter. But that's nice and clean now. Now I can come through, cut my whole strip. Key issue is to make sure this finger is not overlapping what you're going to cut. Someday you're going to be tired and you're going to cut right through your finger. We've all done it. I have a scar right there from a long time ago when I was a second-year student, slicing my finger right off. And then blood splatters, it hurts real bad, and hopefully you never do that again. So take this out, now we can set that aside. Cut our little piece. That. Let's say we cut this other one. Okay, so now we have, let's say, a long end and a short end of a future little building component, like this. And as we start to think about how to put these together, you want to make sure you make a conscious decision. Either this piece caps the end of the short piece or vice versa. And so when you do the other side, you do it exactly the same way. It either caps one way or the other. Right? Now, when we start to glue this up, we're not going to try to glue this. Okay. So I usually have a sacrificial piece of chipboard. I can pour out some glue on it. I have glue, and then use the really important tool, which is your finger, right? So dip a little bit onto this and then run that bead of glue along the edge of the chipboard, right? Look how clean that is. It's not dripping all over. If you got some on your finger, you just wipe it on the underside of your desk, right? That's what that's for. Now come in this case, I'm going to cap it this way, right? And I can see a little shadow line if I'm not lined up correctly. I can get that on, right? Go ahead and lay this down, use gravity to my advantage, and then get my square, and the other square, right? And now that'll dry up real nice. So I could leave it there for a few minutes. I could go do something else. I could let it set up. I could check it. Right? Yeah, looks pretty good. Wipe any excess off. Put it back on to dry. right? So that's the basic principle for chipboard to make any of these kind of larger pieces, or if you're just doing a study model, you can leave the chipboard in its smaller 1 millimeter dimension. Okay. So the trickier part of this, the more sort of delicate component, is if you ever want to make a sort of screen wall like this, right? As we pointed out earlier, you're going to have elements that run one direction that are closer together, and then elements that run the opposite 90 degrees perpendicular to those longer pieces. And that's what you'll glue to, right, to make this structure. So in order to do that, we have to decide how long we want the major pieces. And actually, I should have shown you this earlier. We also have some options for dimensions of these components, right? From super skinny, like less than 1 millimeter square, maybe 0.5 millimeter square, like these pieces, to 1/32 square, which is roughly 1 millimeter. And then we could also get into, imagine if you're doing a horizontal louver and you want that to stick out a little bit further, you can use a piece that's wider than it is deep. I tend not to use elements that are much larger than this. We can see this if we go back to the screen before. We have very thin and very thin here horizontally, and then a slightly larger piece for the kind of gravitational structure. Okay, so if we're gonna make a screen like that, what I recommend doing, taking a piece of place, laying it out, you don't have to be super fancy about this because it's not like a drafted drawing or an important drawing. Just kind of make up something here. And then if you were really doing this and serious about it, instead of eyeballing, you would want to do this more precisely. For our purposes, this works fine. Okay, so then you can notice on this example how the horizontal elements or slats are not spaced equally. Here they're more dense, then they get a little more open, dense again, and then a bigger opening, right? And so we can do a similar pattern here. We have a piece on the bottom. We get our pattern working. That was terribly done. Missed a one there. All right. But again, better to actually come in here, measure these. I should stop trying to cut corners and do it correctly. It's an example of what goes wrong when you cheat. Don't take your time. All right, that's a little better, more consistent. So we'll use that one instead.
You have two examples about student pictures.
Exactly. Okay. So what we're gonna do is run these four first. We're gonna cut them long and tape them down so that, let's say we'll use these pieces. So in this case, it doesn't really matter how long these are because we're gonna come back later. So what I wanna use. So this chopper is kind of an amazing little machine. It's just a regular razor blade, somebody might have shaved their beard with, and a straight edge. And you can run these things however long you want. This is an angle or a stop that you can decide they're all going to be that dimension and make repetitive cuts so they all come out the same length. In this case, I'm intentionally going to run them a little long. 4 of these. Here. So I'm lining those up with the underlay. I want it to be precise, it doesn't really matter. Need a little more tape. Let's do that this way. I can see that any time they're a little deviated. Okay, so those are where they need to be. Now I can measure this. It's 2 inches exactly. And I can set this up. So what I'll do is take this, make this out of these little skinny ones. Measure 1. Let's see it. Exactly 2 inches. I'm still not very good with the metric system after 15 years here, so what's 2 inches? 5 centimeters, roughly? Something like that?
I don't know.
You have no idea. So I'll get this lined up, put the blade right on my mark, then I put the stop where it needs to be, turn these little guys, tighten them down, and now that stop can't move, right? So make a click, there's my 2-inch piece. I'm gonna have a whole bunch of these, so I'm gonna make a bunch of cuts. You can imagine how long this would take if I had to measure every single one of these cuts separately. I'd be here all day. Okay, that's enough to demonstrate what we're doing. So now I'd have a hard time with my fat little fingers if I was trying to grab that and put it down, like my finger hits before I can get it to attach. So that's where our tweezers come in, and our little blob of glue. See if it's still working. Yeah, that works, still works. So now I'll use the piece of basswood to apply glue using the underlay. Okay, now I can take the excess off. Fingers are multi-purpose tools. And I can look down on that and see that now my basswood lines up with that underlay line, right? If I think, oh, that's a little bit extra glue, it probably doesn't matter because it's gonna dry clear. But if I was worried about it, I could carefully take the tip of my tweezer, take it off, wipe it on my finger. You can wash your fingers later, it's not that big a deal, right? And then I can just repeat the same process. What I'll generally do is start though at the top and the bottom so that I know all the main rectangle is gonna stay in case the tape lets go or something. That. Just push that down, hold it for a second, and then it'll stay. And then you just repeat that over and over. Just put one in the middle here. If your glue starts to dry up, just put another dab of glue down on your chipboard. This is better when you have your headphones on listening to something good, like, I don't know, Angie Stone, who just tragically passed away last week. So we could keep going here, right? Mm-hmm. All this dries up. It's loose. You can just put a little downward pressure on it until the glue sets. Whoop, see that? It pops up a little bit. And nudge it back and forth. Get it lined up where you want. Let's pretend we have all those done, right? Set up for a little while. Then what we're gonna do is we're gonna come back and cut each of these points, right? Cut here, here, here. And that way we know they're all the same length. The trouble is, if we didn't run these long and tape them down at beyond the sort of perimeter of our piece, there'd be nowhere to glue, or nowhere to tape that wouldn't interfere with the glue, right? So that's why we're sacrificing a little bit of this basswood to make sure that we get this done correctly. Now, when you do this, you don't even really need to worry about, this is still not dry, but I'll demonstrate anyway. You don't need to worry about having the cutting mat on here as long as you're gentle when you cut through here. You'll hear it snap at some point. Whoop. Oh, I'm messing this up because it's not dry. Imagine, there you heard it snap, right? Then I can take that away. Fix it actually now that it's still wet. Get that lined up, right? And so you would do the same thing again once it dries. Give it a good 10 minutes probably after you put the last slat on for the whole thing to dry correctly. Then you can cut them off, easy, all done. Okay, I think that's it. One more thing I thought I'd show you. There are different types of basswood that you can get that actually have, in this case, grooves to replicate a kind of corrugated metal. You can see it's got grooves on it, smooth basswood. And then you can also, if you ever want to represent translucent glass or glass block or something like that, you can get thin 1 millimeter thick plexiglass and just sand it, right? And then there's another tool that you have to use, which is called a plexiglass cutter. It has a kind of hooked blade on it that allows you to cut that cleanly. So that's essentially all the tricks and tools that we use to make these pretty exquisite smaller scale models. Right? We can go to my office real quick and see some examples of that, hopefully as inspiration, and then you can get started making good stuff.